Good afternoon. I was waiting to see the arrival time of Senator Hutchison, and so what we'll do is go ahead and get some of the introductions done so that when she arrives that we'll be able to get right into the meat of the hearing. I want to thank everybody for being here in what is going to be an extraordinary hearing. It's interesting that today is the 50th anniversary of President Kennedy's speech at Rice University, where he said, "We choose to go to the moon." And that bold challenge would be met within 7 years. And when Neil stepped down that lunar lander ladder onto the surface, it was one of the country's proudest and most riveting moments. It was an event that reminded us how triumphs can unite the people of our nation, and indeed, I happened to be a lieutenant at the time abroad, and I saw that unification of the people of planet Earth at that time. And we reflected on such a triumph earlier this summer when Curiosity landed on Mars, and we reflected on the ingenuity and talent that is required for those extraordinary achievements a few weeks ago, when sadly we heard of Neil Armstrong's passing. And so tomorrow morning at the National Cathedral, the country will bid farewell to one of our most cherished heroes. And it's with his spirit in our hearts and President Kennedy's vision in our minds that we look today at NASA's overall exploration program. The whole world was captivated by the harrowing landing of the rover. I have seen it. It's as big as a Volkswagen. And we continue to be fascinated by the amazing high-definition images that we're getting back from the rover's landing site. We're fortunate today to have members of Curiosity's team here to kick off our hearing with a mission update. We'll hear from Dr. John Grunsfeld, the Associate Administrator for NASA's Science Mission Directorate, Dr. Fuk Li, the Director for the Mars Exploration Directorate at NASA's JPL, Dr. John Grotzinger, a Professor of Geology at Caltech and the Project Scientist for the Curiosity mission. And after that update, we're going to move on to our witness panel, where we'll be examining the progress of NASA's exploration program under the NASA authorization bill that was passed in 2010, particularly as it relates to a future human mission to Mars. So our witnesses include Dr. Stephen Squyres, the Goldwin Smith Professor of Astronomy at Cornell and Chairman of the NASA Advisory Council, Dr. Charles Kennel, Chair of the National Academies Space Studies Board and Director and Distinguished Professor Emeritus at Scripps Institution of Oceanography at the University of California at San Diego, and Mr. Jim Mazur, President of Pratt & Whitney Rocketdyne, a company that does a lot of things, but it also specializes in rocket propulsion technologies. And so I want to welcome all of you here today. Would you all, Dr. Grunsfeld, would you like to introduce your team?
Certainly. I'll introduce to my left Dr. Li, and he'll work from there. But I just want to make a quick opening comment. First of all, thank you very much, Senator Nelson, for inviting us here, because this is a spectacular result that we have a successful landing of Curiosity on the surface of Mars. My hopes and dreams for this mission were that even just the 7 minutes of terror leading up to a successful landing would be as significant for kids today as Neil Armstrong's landing on the moon, of America's landing on the moon, was for me. That led me into science and studying math, and eventually to become an astronaut and now an associate administrator at NASA. Those famous words of President Kennedy said, "We do these things not because they are easy, but because they are hard." And when, in the cause of science, we challenge our teams to do things that are not only a little bit hard, but things that many would say are impossibly hard, I think that's what brings out the best in scientists, engineers, technicians, and people who are excited about exploration. And I think there's no more qualified team and no more team that's more excited about exploration right now than the team that's driving a rover on the surface of Mars, the Curiosity rover. And with that, I'd like to introduce Dr. Fuk Li, who's the manager of Mars exploration at the Jet Propulsion Lab.
All right. Before I turn to Senator Hutchison, why don't you, Dr. Li, introduce some of your team that is here in the audience?
Thank you. There are two additional members of the Curiosity rover team who are with us besides John and I. Rob Manning here, he's the chief engineer for the project, and he was responsible for resolving a lot of technical problems we have on the spacecraft and in development. And this is Beth Duell. She is the lead of our telecom uplink. When we try to talk to the rover and ask it to do what it's going to do in a certain day, she's always involved.
So she's the driver.
She's right.
Thank you. Let me turn to my colleague, and before I do, let me say that this may well be the last Science and Space hearing for Senator Hutchison. Because, unfortunately, she has chosen to retire after a very long and distinguished public service record. I can tell you that I mourn the fact that she is retiring, because Kay and I have demonstrated how you pass legislation when it should not be partisan, and where there was no daylight between the two of us. And thus, in the midst of what was tumult back in 2010, we were able to pass the NASA authorization bill unanimously out of the Senate, first unanimously out of this committee, and then with a 3/4 vote out of the House of Representatives at 11 o'clock at night on the last night of the session. And so I cannot say enough good things about Kay and her leadership and her passion for America's space program. So with that, let me turn to you, Senator Hutchison.
Well, thank you very much, Mr. Chairman, and I'm so looking forward to hearing from you. I had actually hoped we might have one more hearing, because I do want to look toward the future, and I think one of the things that we've been missing here is the protection of the future, not just always going as far as we have to go right now, but making sure that we look to the future. And when the Curiosity landed, I saw for the first time really in a long time that enthusiasm of America, just seeing the precision of that long trip and the landing. It showed that we really can conquer so much more. And so I wanted to have this hearing, and the chairman wanted to have this hearing to highlight what is the future, and maybe we can eke out one more hearing, but we have been a wonderful partnership in assuring that NASA is not undercut so severely that we can't keep our preeminence. And if you would just give me one moment, I want to say that this also is the 50th anniversary of President Kennedy's speech at Rice University, where he laid out the wonderful vision. And I would just like to take one little quote from there. He said, but why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why 35 years ago fly the Atlantic? Why does Rice play Texas in football? And then he goes on to say, we choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. And that inspiration that President Kennedy gave us must be continued, and that is, it has been my goal, and I hope that as we are looking toward that next step, beyond low Earth orbit, onto other parts of our space, including Mars, that you will help us fashion that vision. And so thank you, Mr. Chairman. Thank you for all you do in this regard. And I will end by saying that tomorrow we're going to honor the first man who stepped on the moon. And I know we both plan to be there because Neil Armstrong stood up last year when he too was worried that we might be sacrificing the future for the present. And as shy as he was about publicity, he took a stand, and that, I think, made a huge difference in the course that we have been able to take. So with that, I want to hear from our witnesses.
Good.
Thank you.
Dr. Li?
Thank you, Mr. Chairman, for giving us this chance to talk to you and give you a short update on where we are with Curiosity. But before we do that, I would like to say my deep gratitude for your support that has allowed us to develop, to fly, and to land this rover a little more than a month ago. The support that we have gotten in the past decade and we're getting now has created three significant capabilities in the nation. The first is a set of strong Mars scientists. Many of these scientists are working in universities across the nation, and many of them are working with John in the day-to-day operation of the Curiosity rover, telling it where to go and what to do. The second is it put us in a preeminent position for the technological know-how, how to land on a different planet. Looking back to the Sojourner rover that landed in '97, it was about 20 pounds. To today's Curiosity, it's about 2,000 pounds, the size of a small car. This increasing capability is really unique to America. Finally, it also put us at the forefront of advanced robotic technologies to allow us to operate a rover millions of miles away from Earth in a Martian environment that is cold. Sometimes we don't know what it is, and sometimes it's unfriendly to us. So with that, I'd like to go back to the landing night and show a video that is about 2 minutes long and show you the landing event. We were clearly very excited and want to share that excitement one more time. When Curiosity went into the Martian atmosphere, it was enclosed in a capsule to protect it. When it went into the atmosphere, it moved at about 13,000 miles per hour. The kinetic energy of that capsule is roughly equal to several hundreds Formula One race car going around at 200 miles an hour. The protective heat shield slowed the capsule down, and this video starts by the next stage when we start to deploy the parachute. I'm going to start a video.
We should have parachute deploy around Mach 1.7. The parachute is deployed.
So this is a picture taken by an orbital flying overhead of
Beach has separated. We're on the ground. We're down to 90 meters per second at an altitude of 6.5 kilometers descending. Standing by for backshell separation. We are in powered flight. We're at altitude of 1 kilometer descending. Standing by for sky crane. Sky crane is started.
signal to us. You remain strong.
Touchdown confirmed. We're safe on Mars.
Today, right now, the wheels of curiosity have begun to blaze the trail for human footprints on Mars. This is an amazing achievement.
Well, today on Mars, history was made on Earth. The successful landing of Curiosity marks what is really an unprecedented technological tour de force. It will stand as an American point of pride far into the future.
So with that, I'd like to turn the time over to Dr. Grotzinger. He is a professor of geology at Caltech, and he's the project scientist that leads the science team for this mission. And early results he showed, to me, they show a lot of promise for future exciting science discovery that can only be made when we're on the surface of Mars and interacting the material on Mars. John?
Thank you, thank you very much. Thank you very much, Senator Nelson and Senator Hutchison, for this chance to present some initial science and some fun pictures. I guess I just press this one. So here's our landing site. You see it way out in space, and you can see a lot of big craters around there, but the one that we chose to go to has a mountain in the middle. Mount Sharp, as it's known, named after a pioneering planetary geologist. And if you go in closer, you can see now Mount Sharp. The area represented by the crater is a little bit larger than the area of the state of Connecticut and a little bit smaller than the state of New Jersey. So it's an enormous area that we have potentially for exploration. But our goal, you can see the landing ellipse just right here, and then that's the spot that we landed on. And our goal is to do some exploration around in this area for the next month or two, and then begin a long trek that will eventually take us into the foothills and up the flanks of Mount Sharp, where we believe there's evidence for water that has once interacted there and could be the very target we're looking for. To give you a sense of how bold this goal is, you can see Mount Rainier there, which is smaller than Mount Sharp. Mount Sharp, its elevation is greater than any mountain in the lower 48 states, including Mount Whitney, and you can see it's just a tad lower than the highest mountain in the U.S., Mount McKinley there. This is looking after we landed, one of our first color images that really gives a sense of just how dramatic the landscape is. This is looking towards the crater rim, not towards Mount Sharp, but the crater rim. And we love this photo because those of us that teach geology out in the West often take students to Death Valley area. And you look out across towards the mountains, you see a little LA smog coming in there, and it just looks really familiar. It just seems like a very comfortable place for us, and we love this landing site. Here's kind of a fun outreach instrument. We have a laser on board that the public has really enjoyed. They've looked forward to this a lot. It allows us to reach out maybe 10 feet away and zap a rock, and it tells you whether or not it's the right rock to go up and spend some more time doing more detailed work. And in fact, when we do that, this is what you see. There's a little scale bar here on the right, so it's just a couple millimeters, and the dot that you see here is less than a millimeter. And if you felt the laser, if it actually zapped you, it might sort of tickle you a little bit. So that's what actually happens. But what the rest of the world thinks is happening is this. And, you know, they're just having a great time. The people, if you look on the internet, they just love this mission, and they're really enjoying it. This, to me, is really one of our great moments. This is our first footprints on Mars. You look back to the upper right. This is where the rover landed. These are the 1, 2, 3, 4 marks made by the thrusters as they impinged on the surface and blew the soil away. And here you see wheel tread marks where they begin. and it tells us about our future on this mission and where we landed successfully. We're now driving away from that place. It might be the last time we ever see it that well. We get further away, but we will never forget this image. Here we are now looking towards Mount Sharp, which is our ultimate destination. It's a 360-degree panorama, and you can see the same 1, 2, 3, 4 blast marks there. And the elevation change from this point up to the top of Mount Sharp, it's blown up here, is on the order of 3.5 miles high. So it's a tremendous goal that we're trying to strive towards here and exploring at least the base of that mountain. And when you get up close, this is another one of the images. It's my favorite. I believe it's probably the team's favorite image. If you look at the foothills, which are about 6 miles away, there's a little black rock right here, which is blown up in this box here. That rock gives you a sense of the size of the rover. When we get there one day, we're not going to be able to look back towards it. We see it now and we imagine our future. What will happen as we blaze a trail going up these valleys and look around the corner? Team is just filled with wonder, and the people that are following the mission are filled with wonder as we look towards this spectacular area. And finally, I want to finish with an image that's just 2 days old. We have 17 cameras on this mission, and one of them reaches out from the end of the arm and can look back towards the rover. And the principal investigator who built that camera, Ken Edgett, put a penny on the rover because geologists do this all the time on Earth. We need a scale. We pull it out of our pocket, we rest it gently on the rock, and we take a picture of it. And it's a standard practice for us. But this symbol for us has so much depth to it. It's the great thing that this country has achieved through your support to be able to have this mission succeed and even be able to see this image. And so I, on behalf of the 406 scientists and all of the engineers, probably 1,000 people currently working on this project, want to thank you for the support. And the last thing I want to point out is something that history will take note of, is that the year here is 1909. The penny was embedded with the anticipation that we would launch in 2009. And we were not able to, and we hit a lot of obstacles along the way, and we needed support, and it came from you and it came from NASA, and we are ever so grateful for that because we got where we wanted to be. So thank you.
Tell us about when you put the packages together and you send it up there. How many minutes do you say it takes to transmit to Mars?
Right now, it takes about 15 minutes to go one way from Earth to Mars and from Mars back.
Tell us about how you go about planning what that package of instructions is going to tell the rover to do.
Okay, maybe John, you can describe one day in the life of a rover.
Okay. One day in life of the rover starts with us working on Mars time, and because Mars has a slightly different orbit, it's 24 hours, 39 minutes. We have to adjust every day. So the science team gets jet lagged every day by another 40 minutes. We get up, the first thing we do is we see the data that arrives from the spacecraft back down to Earth. Science team looks at the data, engineers look at the data. We quickly assess what it is that's there, and then we see if that matches our plans from the previous day about what we'd like to do next. Then we go ahead, and it results in probably about 2 hours of tactical decision-making where we come up with a list of observations that we would like the rover to be commanded to do. Then we go through another meeting where those observations are confirmed to actually fit within the block of time, energy, and data that's available as the three resources that restrict our behavior. And then we go through a process where those activities are all vetted amongst another group of engineers that come on a second shift. And then eventually, another 6 hours later or so, these are all confirmed, vetted, cleared, and then somebody pushes the button that radiates the command sequence up to the rover.
And in your exploration to determine if there was water there, what is the process by which you do that? Are you looking for chemical composition of the soil and rocks?
It's a mixture of both analytical chemistry and also observations with the cameras. And through this, we're able to merge these observations together, much like was done on MER with Spirit and Opportunity. But now when we find something that looks like it was a rock or a soil that formed in an aqueous environment, we can dig much deeper into it to begin to really understand whether or not that aqueous environment might also have been an environment that could have supported life had life ever existed on the planet.
Just to follow up on, we always hear that the most important thing that we could find is that there might be evidence of water, which then might lead to some thought that there was some kind of life. My question is sort of on the same line as Senator Nelson. If you found something that appeared that it might have been formed with a water or aqueous atmosphere, will you then be able to, what all can you tell? Can you tell how long ago it was? Can you tell, is there anything in that would also indicate life or not, or where the water would have come from, or what else can you learn if you think there is a water component?
What we would be able to do is, with our increased capability on MSL, is we really get a sense for what kind of environment it was specifically that the water was present in. Was it there for a long period of time? We'll be able to do that a little bit better than we have in the past. But mostly we get a really good chemical assessment of how not only the water was present, but whether or not the environment could preserve organic compounds, which is very important for us as a science community, because when you stop short and ask the question about can you ever hope to someday find evidence for life on Mars, you first have to look for the calling cards, at these traces, if you will. We call them chemofossils, little bits of chemical evidence that suggest this is the kind of place that you should go back to and look in more detail. And our hope is that if we find such bits of chemical evidence that will be quite a rich record, this would be the kind of place you'd want to go back to and do sample return, for example. You're going to want to go to progressively higher levels in your analysis, and that's just the way we do it on Earth. You go out to the field, there's lots of different rocks to go look at. You never know kind of which one, but you zoom in on it, and it is an iterative process until you bring something back to the lab and then finally know that you found something really significant.
Will you be able to tell how long ago it became extinct or the water went away?
Yeah, we have the benefit of the Apollo astronauts who brought rocks back to the Earth from the moon that calibrated the crater rate, and so we kind of apply that to Mars, and so we have a rough sense of how old these rocks are there at Gale Crater. They're probably in excess of 3 billion years, somewhere between 3 and 4 billion years old. The harder question is to really ask, if we see evidence for water, how long was that water around for? But we do have an instrument that if things go in our direction, it's a long shot, we might actually be able to date the rock that's there and get a sense for how old that water was there.
How fast, you're talking about an area bigger than Connecticut, how fast can the Curiosity move so that it can cover the amount of land that you're trying to cover in the time that you have?
This is a great opportunity for me to talk about, just mention briefly how important the Mars program is. Because it's an iterative process with rovers alternating with orbiters, we have orbiters that make maps of where we think the good stuff is. And so when we picked our landing site, we picked the landing site, and then we were able to move the ellipse down in there, and we moved the ellipse very close to a place that from orbit looked really good. And, you know, I'm conservative by nature as a scientist, and I'd like to wait a little bit longer, but I think we're a few hundred meters away from a place we feel pretty comfortable we're going to be able to show if the rover was formed in water. And then after we explore that for a while, We're going to take that long drive, and it could take, half a year to 9 months to get to the base of Mount Sharp, but then we have another series of opportunities there. So I think we've got an exploration portfolio with many different options in there, and we've just had a little bit of serendipity. It wasn't total luck that we wound up in this very special place, but I think we're going to be strong right out of the gates here.
And just last question, is there a time limit in which the rover will be effective and the computers all work, or do you have a fairly unlimited amount of time?
Well, we tested the spacecraft to deliver a 2-year mission, and in comparison, MER was built to go 3 months, and we're going on 8.5 years. So after 2 years, the warranty wears off, according to the manufacturer, but we're looking forward to a real long mission after that, too, I hope.
Oh, good. So it could be years that you will keep roving around and poking.
Yep, we hope so.
Good. Okay. Thank you.
As a matter of fact, Curiosity can greet the human crew when they land. You have any opinion as we try to develop the technologies and the life support systems that would take us to Mars in the 2030s? Do we need a sample return mission first? Just your opinion.
My opinion.
Your opinion.
I think the architecture that the Mars Sample Return Program has laid out in the decadal survey that we as a community fully embrace is the right step to take to get us on the way to putting humans on Mars. You must have this capability to land something on the surface of Mars and get it back off again. And if the technology demonstration for that human step is to bring back some rocks from a carefully chosen place, we will be all the richer for it.
Okay, well, we want to thank you. This is an exciting update. Congratulations again on making the country proud and seeing you all jump up and down was a delightful sight. Thank you on behalf of a grateful nation. Let's call up the second panel. We have Dr. Stephen Squyres, who is the professor of astronomy at Cornell, Dr. Charles Kennel, chair of the Space Studies Board of the National Academies, and Mr. Jim Mazur, president of Pratt & Whitney Rocketdyne. So, Dr. Squyres, we'll start with you.
All right. Well, Senator Nelson, thank you very much for the opportunity to appear here today. My name is Steve Squyres, and my title is the Goldwin Smith Professor of Astronomy at Cornell University, and I'm currently the chairman of the NASA Advisory Council. A central focus of the NASA Authorization Act of 2010 was the development of two crucial and highly capable elements of a deep space exploration system, the Space Launch System and the Orion Multi-Purpose Crew Vehicle. NASA's development of both SLS and Orion is well underway, passing crucial milestones like successful test firings of SLS's J2X cryogenic upper stage and the delivery of the first Orion command module to Kennedy Space Center. And what will these vehicles be used for? President Obama has called for sending humans to an asteroid by 2025, to Mars orbit by the mid-2030s, and to the surface of Mars subsequently. These are grand goals, and they're broadly consistent with the goals that were expressed in the 2010 Authorization Act. I see two possible areas of concern. One is that a pay-as-you-go approach can result in slow progress if funding levels are not adequate. There's been no human-rated launch system in NASA's history that has had a flight rate as low as the one that's currently projected for SLS and Orion. And with such a low flight rate, it could be challenging to keep flight teams sharp and mission ready, as well as to maintain program momentum. Another is that the SLS-Orion combination, of course, was never intended to carry out missions to important destinations beyond low Earth orbit by itself. Additional vehicles are needed. For example, an asteroid mission requires hardware that's capable of providing crew support in deep space for many months. A lunar surface mission, which also could be a stepping stone to Mars, requires a lunar lander. But there's no funding in NASA's budget to develop such vehicles. Stated plainly, NASA's budget today is insufficient to carry out the administration's plan on the stated schedule. Now, SLS and Orion will be highly capable, and their development is progressing very well. But they're only part of the picture. And without the means to develop or acquire the missing pieces of the puzzle, a decade from now, NASA will be unable to do much more in deep space than duplicate the success of Apollo 8's historic mission to orbit the moon more than half a century later. I agree with the 2010 Authorization Act that, quote, a long-term objective for human exploration of space should be the eventual international exploration of Mars. In fact, in my view, it should be the long-term objective for human exploration of space. I also believe that robotic missions should serve as precursors to human exploration, both to collect engineering data and, critically, to lay the scientific foundation on which human exploration will be built. In the recent National Research Council Planetary Decadal Survey that I chaired, the highest priority flagship mission identified was a Mars rover that would initiate a campaign to return samples from the surface of Mars. Unfortunately, NASA has been unable to follow this NRC recommendation because of deep proposed cuts in the FY13 budget for planetary exploration. The mission would have been carried out in partnership with the European Space Agency, but that partnership has not come to fruition because of these cuts. With such deep cuts, the scientific investigation of Mars that should provide the underpinning for future exploration by humans is in jeopardy. And the NASA Authorization Act of 2010 provided the agency with a clear set of goals and priorities. The administration has also articulated its own vision. And these two sets of guidance are not dramatically different, but together they call for more than the agency can do with the budget that it currently has. A mismatch between objectives and resources is the reason that a crucial piece is missing from our development of a robust capability for human exploration of deep space. It's also the reason we've seen deep cuts to a program to explore the very solar system body to which we hope humans will one day be sent. Now, this mismatch could be corrected by making some painful choices, eliminating some of what NASA does to preserve full and adequate funding for other things that it aspires to do. That would, however, require a new and much more narrowly focused national consensus on priorities for NASA. Alternatively, and much more attractively, the agency's budget could be increased, although I realize that that may be difficult in a constrained budget environment. One other possible approach would be to broaden NASA's capabilities by forging strong international partnerships, as has been done so successfully for the International Space Station. Right now, there's no real plan for international participation in NASA's future human exploration beyond Earth orbit, and the hope for collaboration with ESA for future robotic Mars missions has been set aside, at least temporarily. But international collaboration is a path that could hold some potential, I believe, for bridging the gap between what NASA is being asked to do and what its budget allows it to do. Thank you.
Dr. Kennel.
Okay. Is this on? Yes. Thank you. Thank you, Mr. Chairman and Senator Hutchison, for the invitation to testify. I have some written remarks longer written remarks I'd like to submit to the record. My topic today is leadership. Let me start with who I am, because I have a comment I'd like to make. I'm Charlie Kennel. I'm chairman of the Space Studies Board, a professor and director emeritus at the Scripps Institution of Oceanography, and I'm proud to say that my predecessor as director, Roger Revelle, was on the platform at Rice University when President Kennedy made his inspiring speech. I must say that Scripps cannot accept the incredible challenge of playing Rice in football, however. But nonetheless, I think curiosity teaches us that when you set a goal that is extremely difficult to achieve, then NASA will beat the odds. So I'm going to talk about goal setting, clarity of goals, and leadership in space. And I'm going to spend most of my time reviewing what our Space Studies Board has done, but I'm, of course, going to base a lot of my personal remarks on my experience 12 years on the NASA Advisory Council, 4 as chair and associate administrator, and on the Augustine Commission. In human spaceflight, I believe the International Space Station guarantees our leadership for a decade, especially if U.S. utilization is strengthened. And there, your miraculous act asked the National Research Council and our Committee on Physics and Biology and Space to lay out a program for space science utilization in our most recent decadal survey. And I'm pleased to report some promising developments, that NASA has created a new and independent office for physics and biology in space. They are beginning to work very hard to reconstitute a discipline that was basically destroyed by earlier budget cuts, and they're making progress on a non-governmental organization, user interface organization. And so I think we can see good progress in that area. But the question before us now is, what will constitute human spaceflight leadership beyond the coming decade? And as Steve has indicated, there are many factors there, and he's reported on the important direction that you gave to the program that is moving forward. One piece of direction you gave also to us, and you asked the National Research Council to undertake a study of the goals and core capabilities and future directions of spaceflight beyond the decade. Now, this is a very complicated study. Scientific and technological, sociological, national security, international relations, even philosophical issues come into what should the goals of human spaceflight be over the long term. What kind of goals can we set as a country that will keep NASA and the country coming back to making and attending to the achievements that it intends to make, even though there are budget fluctuations, policy and administrative changes? Where are the long-lasting goals that can serve the program through mid-century? I'm pleased to say that a distinguished committee, you'll be impressed, is about to be announced. We've worked very hard to develop stakeholder and public consultation plans, and in my belief, this is the most potentially innovative study that I've been involved with. It is also the case that since so many factors besides science and technology going into setting into this goal, that we're going to draw on the full resources of the National Research Council in many different areas of endeavor beyond those that the Space Studies Board and the Aeronautics and Space Engineering Board oversee, but we will be principal supporters of that. Now, in this year, I'm now going to move on to leadership in space science, and I will end with some remarks on Mars. Just this year, we completed a round of decadal surveys and a mid-decadal survey that looks over all of the subjects of space science that NASA deals with. And I think that these recent decadals are going to be the best picture of contemporary state of American space science that you're going to get in the near future. And of course, there are many, many, many things that were discussed in careful detail. The community was consulted, dozens of white papers came in and so forth. But from all of that, I'm just going to extract the leadership elements, the ones that inspire people to work beyond their capabilities and to beat the odds. So first, here are some of the things we need to do for leadership in astrophysics. Stay the course with the James Webb Space Telescope. Despite all the difficulties, it is still a leadership instrument in astronomy and astrophysics. The scientific rationale for it has developed considerably since 2000 when it was first proposed. It can now do extrasolar planets with a good capability. And if we abandon it now, we risk abandoning world leadership in the entire subject of astrophysics, just as the event with the superconducting supercollider did, unfortunately, for American high-energy physics. Next, we have to capitalize on American leadership in the dark energy area. And we need to find a way to get the science done that was proposed by the first priority new mission in our most recent decadal survey, the Wide Field Infrared Space Telescope. the implementation is less important than achieving the goals of maintaining leadership in dark energy science, where we started, and also to continue the work in exoplanets that it was able to do. In the next two areas I'm going to treat together. They're in some ways very different, but they have something in common. One is heliospheric physics, solar terrestrial physics, and the other is earth science. And of the many issues that they have separate, they have one in common, and that is that the goals that they set for themselves depend in serious ways on interagency coordination, which is where I believe this committee can play a serious role. In heliospheric physics, it's on the verge of a very exciting new capability, the ability to predict space weather and the impacts on spacecraft and ground systems from solar storms. It's on the verge of becoming an operationally useful subject. At the same time, earth science, our most recent report, suggests that earth science is on the verge of defaulting on the science and applications obligations it has thus far successfully carried, because as we look forward into the future, the number of spacecraft devoted to this area, it looks like it's going to diminish dramatically. And in both cases, there needs to be collaboration between NASA, NOAA, the U.S. Geological Surveys, and other agencies in order to set the goals for these programs, and congressional and administrative leadership is required to settle these roles and missions. Now, you've heard this many times. You've got coordination fatigue. How many times have you heard this? But there may be one area where the science community can help you out as you try to figure out the roles and missions of the agencies whose coordination is essential to their success of these projects. Perhaps we, scientists and technologists and users, could identify key variables and standards of measuring those variables that need to be sustained over the long terms as part of a national commitment. And at that point, maybe the agencies will see more clearly what their role is. But they need to look at these variables not only from their measurement in space, but what requirements will be placed on the ground systems to analyze the data, what standards we will use for exchanging data, and how we decide to preserve the data in long-term archives. So now, as promised, I come back to planetary science. There's very much more to planetary science than Mars, but I'm going to focus my remarks on that for the moment. It's leadership science in its essence. Even landing on a planet is something that most people cannot do. Most countries cannot do it. And as the senator mentioned, we believe that with good luck, our energy source will last, and Curiosity is going to return unmatched science for as much as a decade. The scientific community will continue to be very busy. And we didn't expect to have to come before you and say this, but the future direction for Mars beyond that, which we once thought was fairly clear and secure, has suddenly become unclear. And this is because of the recent cancellation of 2 missions that were designed in consonance with a strategy for research that was put into place 15 years ago, of which Curiosity is the most recent and most spectacular project, a strategy in which the various assets that we devote to Mars work with one another and reinforce so that the whole is greater than the sum of its parts. And you could see it during that landing because they had to move one of the orbiting spacecraft over the landing point to take a picture of the landing, which became so spectacular on the net. And now, from my point of view as a scientist, those missions were canceled without a clear explanation that's based in science. And Visions and Voyages, the decadal study that Steve chaired for us, provided a similar guiding principle for the next few decades, just as the strategy of Follow the Water led to the sequence of missions that that right now is ending in Curiosity. The guiding principle for the next series of missions is sample return. Now, and there's a, and it's a guiding principle. Don't, if you're going to spend big money on Mars, don't spend it on things that diffuse our focus. Spend it on the ultimate goal, sample return. Now, why is sample return important? Because when you bring it back, you can bring the full potential of thousands of laboratories around the world to bear on understanding the place where the astronauts are going to land or the characteristics of it. And we also see from the Lunar Science Institute that 50 years from now, those samples will still be used for new science that nobody thought of at the time. I'd like to make a point. Sample return is no more a call on present resources than is the goal of a Mars human landing. Both of them are long-range goals, and but they focus the use of resources that we do have on a goal that will eventually add up. And so, to my way of thought, and as a part of a Space Studies Board, the unclear goal, the destruction of a clear, or the suspension of a clear goal that was guiding our thinking and making our efforts synergistic is the most serious outcome. It can be repaired. Perhaps the process of repair is underway right now, but I cannot predict. At the present time, NASA is conducting a serious study of how the human spaceflight enterprise and the Mars science community can collaborate. Now, what's really important from all of this, from my point of view, is that there be a clear set of goals where collaboration enhances the leadership of both areas, and not just identify a few nice-to-haves where we can work together. It is essential to harmonize two essential goals: sample return, understand the environment on Mars and the possibility of life, two essential goals, and landing on Mars, that are both share the commitment to leadership, but are only partially synergistic in implementation. And it's important to get the alignment of these goals right, because in the past, the relationships between human science, human spaceflight, and the science enterprises has been fraught with difficulty and confusion because of unclear goals. And again, congressional leadership is essential to NASA leadership in this area. And we think that SSB, we hope to be able to help by taking a look at the NASA report as it comes out and looking at it from the point of view of long-range planning and science, just as the NASA Advisory Council suggested we do. So at the end of the day, I would think that my whole talk has been devoted to the need for consistency of vision and goals as essential to achieving leadership in space. And the science, you know this, the science and technology community can weather budgetary ups and downs, even policy changes, cancellations, this and that, but wholesale changes in direction are another matter altogether. And I hope that we have time, I think, to repair the situation. And that's my remarks. Thank you very much.
Thank you, Dr. Kennel. Mr. Mazur.
Thank you. Senator Nelson, Senator Hutchison, thank you for the opportunity to testify on this important topic. I'd like to start by recognizing Senator Hutchison for her decades of public service. You've been a fearless and longtime champion, in particular of education reform, which I think first and most critical element to preserving the future of our space program going forward. And you've been a true leader for the state of Texas, for the nation. I wish to thank you for your dedicated service and wish you well in your retirement. For the purpose of today's discussion, I want to highlight these major themes and concerns. First, the need to create an enduring vision, one that will focus on increasing scope and reach of presence through continuous and incremental steps. The need for consistent, clearly articulated budget that allows the execution of an enduring vision. Recognize that it is NASA's job to define how to execute an enduring vision within the budget they've been given. And finally, to reinforce that the Congress and the administration have decided that SLS is a beyond Earth orbit vehicle of choice, and everyone's focus needs to be on progress that will lead to exploration and the fulfillment of this enduring vision. An exploration of vision that will push the boundaries of innovation. It is my belief that what the 2010 NASA Authorization Act did when it laid out the need for NASA to move forward with the Space Launch System, vehicle, and the Orion crew capsule. For some time now, and especially since the end of the Space Shuttle program, NASA has seemingly suffered from a lack of an overarching, enduring vision for leadership in space science, technology, and exploration. The administration canceled Constellation, then established new priorities and directions, such as landing on an asteroid and funding commercial space capability, consisting of multiple providers without clearly identifying a supporting or market or demand beyond the U.S. government itself. This was done with what appears to be limited coordination and consent from Congress. Because of this lack of coordination, Congress has been compelled to be prescriptive in its legislative language with regard to NASA's specific systems architectures and requirements to ensure at least some level of stability for the industrial base and preservation of unique and critical skills. I believe in order for any of the discourse we're talking about today to be relevant, we must have an enduring, stable vision for NASA that's set by the President in alignment with Congress and budgets in a consistent manner that enables execution over time frames that extend beyond a single administration or congressional election cycle. When our nation first embarked upon space exploration and leadership, the expectation was that we would incrementally and continuously expand our scope and reach of presence over time, both robotically and with humans. As Jay Barbary said in his recent 5-part commentary, we must have an affordable, science-driven method of learning, moving steadily outward in logical increments. I believe we must have clear missions and destinations, and then identify the capabilities that either already exist or need to be created in order to complete these missions. It's really that simple. There is no one right solution to how NASA can achieve this incremental exploration and fulfill their charter. Someone must choose, and we have as a nation, have created NASA to do just that. As such, NASA's determined they need a heavy lift launch capability, and Space Launch System is the answer to that need. The Augustine Commission, in their review of NASA Human Spaceflight Program, made the following statement. The committee reviewed the issue of whether exploration beyond low Earth orbit will require a super heavy lift launch vehicle and concluded that it will. Regardless of the exact mission architecture that is ultimately pursued or the exact heavy mass requirement, the heavy lift launch capability that the SLS will provide is fundamental to its execution and must be pursued with the utmost priority and speed. NASA's entire exploration architecture is dependent upon its capabilities as an enabler. And now that an architecture has been established, it is imperative that it receive adequate funding and in no way follows the fate of the Constellation program. What NASA cannot afford to do is continue the trend of canceled programs, rebaselining, and seemingly random directional changes of objectives and priorities. These fits and starts have cost this nation considerable effort, time, and money with tremendous disruption, loss of critical skills, and little return or progress. Clearly, SLS will be the most capable U.S. launch vehicle, and with the Orion spacecraft and modern ground systems will enable new missions of human exploration across the solar system, as well as benefit high-priority science missions. It leverages and builds upon past experience and technology. This is the time to ensure we get beyond Earth orbit as fast as possible, as cost-effectively as possible, and safely as possible. Once we do that, we can resume true exploration and the innovations and inventions necessary to push the boundaries and explore and live on other bodies. In order to push the boundaries, both robotic and human exploration missions have their place within an overall exploration program. There's been a lot of talk about returning to the moon. SLS gives NASA the flexibility to do that, perhaps first launching robotic missions and then humans. A continual incremental approach to exploration should be the norm. While humans explore the poles of the moons, robots should be characterizing the environments on Mars and its moons. When humans finally explore the Martian system, robots can be exploring the icy depths of the vast oceans of Jupiter's moon, Europa. We must recognize there is no end to this process, no victory dance followed by the abandonment of vital innovation engine for the country, just simply continuous progress. The enormously successful landing of the Mars Science Lab Curiosity is a perfect illustration of another step in this incremental development and exploration, as well as the complementary use of precursor robotic missions in space exploration. I want to stress that NASA's exploration programs are not simply intended to return scientific data. They lead to technologies that can be used and built here on Earth. And most notably, they inspire our nation and future generations to come. Finally, like many other people today on the 50th anniversary of the Rice speech, I have a quote from John F. Kennedy that I use often, and it's a little bit longer, the version you used. We choose to go to the moon in this decade and do the other things, not because they're easy, but because they're hard, because that will serve to organize and measure the best of our energies and skills. And I say that because I'm not nostalgic for the days of the past, and I don't want to relive the glory days, but because President Kennedy said doing the hard thing drives us to use the best of our energy and skills, which in turn creates the need and motivation to expand our boundaries. NASA's job is to do the hard stuff, constantly pushing the boundaries that requires technological advancement. We grow as a nation because it takes the best of our people and capabilities to push the limits of creativity and abilities, leading to true innovation and true inspiration. As such, innovation and inspiration cannot be goals of what NASA does and strives for, but rather is the result. Just as Curiosity's mission spawned innovation, which inspires us all, sustained human exploration will challenge us to future innovations that we cannot even predict. But know from experience will keep us in a leadership position, not only in space, but here on Earth. Thank you for the opportunity to address the committee today, and I look forward to any questions you have.
Well, thank you all. All right, we're developing a rocket called the Space Launch System. We're developing a human capsule called Orion. All of this is happening while the average American thinks that the space program is over because they've attached the visible evidences of the space program naturally to the space shuttle over the course of 3 decades. And when the space shuttle was shut down, that naturally leads people to the conclusion that it's over. And now we are ramping up this whole new system to get us out of low Earth orbit. When Apollo was developed, other than the goal of getting to the moon and back, it was also then utilized for other things. A thaw in the Cold War, in the rendezvous and docking of a Soviet spacecraft and an American spacecraft, which was the forerunner to bringing all of this cooperation that we now share with Russia on the International Space Station. So my question to you all is, as we develop the SLS and Orion, what do you see as the full potential of that system? Mr. Macer, let's start with you. What would be some examples of the types of mission that the SLS and Orion would make possible?
Well, certainly, first and foremost is getting back beyond low Earth orbit again. We haven't been there in a very long time, and this will enable us to do that first and foremost, and start to try out and test all the new technologies that have developed and evolved since we've last been there, and also to leverage at least some of the, and you guys could speak to it better than I could, some of the human science that's been going on the space station as we get out beyond for extended period of time in the radiation environment and in other environments. I think initially that's what it first enables. There are a number of missions. I know asteroids have been brought up as a potential one. We haven't identified one yet, and it looks like it's going to be a hard one to get to, so I think we need some fallback plans. And I know there are some discussions going on about other interesting points where there's gravitational equilibrium between various bodies where we could spend extended durations of times in space, longer than we've ever spent before, beyond low Earth orbit, and learn more about how the human body reacts. I personally believe, though, to get its full fruition is a lot about what Dr. Squyres talked about, is eventually we're going to need a lander. And eventually I think we need a series of missions that are incrementally more difficult. So you can just see there's a general pattern here that I think makes a lot of sense, is you have robotic precursor missions Then you learn to live off the planet, whether it's in space first for a period of time, eventually on the moon for a period of time. And once you've learned how to live off the planet somewhere that's not too far away, then you can start moving to places further away that have been doing robotic exploration. But it never ends. And I think that was the point I was trying to make in my comments. It's not this, because you hear comments about we don't need any more flag planting missions. It's not about one giant mission, you achieve it, hurrah, and then you wonder what's next. You always know what's next. You're always working on it, and it's stable and predictable, and everybody knows what technology we need to achieve that.
Just like we did in Apollo, which was an incremental mission, starting with Mercury, Gemini, Apollo, in an environment that we didn't know anything about.
Exactly.
Until we went there. Let me ask Dr. Kimmel, give us some examples of the types of science missions that would be enabled by either crewed or unmanned launches of the Space Launch System.
Beyond low Earth orbit.
Yes.
There are several. We've already had some precursor missions, for example, robotic sample returns from asteroids, which will give you some idea of the chemistry. There are lots of good asteroids. There's a distant but important security goal that can be achieved by approaching an asteroid with a system of significant mass. It's known, for example, that from time to time asteroids have hit the Earth. 165 million years ago destroyed the environment for the dinosaurs. And if we're going to live for a long time as a civilization, we have to worry about Earth-crossing asteroids. And it turns out that you can predict maybe 10 or 20 passages before they actually hit the Earth when they're going to, and you send a spacecraft there. You don't even have to nudge it. The mutual gravity will move it out of orbit. And the proof of principle would be very useful, and you could get that done while you're doing some science. I think that the main argument for human beings has always been they're very good geologists. They can take a look at what they see and tell you in ways that an automated laboratory can't. And so I think that the picture that I would have, and this is not in anybody's decadal report, for example, go to Mars. You want to go there, landers of increasing sophistication. You might as well set a tough goal of sample return because that tests all the technologies for both landing and takeoff. The sample return gives you deep scientific knowledge. You might even have a couple of them to characterize with the most reliable knowledge where you're going to land, then you go.
And congratulations to the Curiosity crew.
Yes, indeed.
That indeed you are part of the forerunner of the first number of steps. And Dr. Squyres, tell us what types of planetary science missions does the unique capability of the Space Launch System, this new big rocket that's evolvable in size, what does that provide?
Well, like Dr. Kennel, I'm excited by what we can do at an asteroid. I was recently part of a 4-member NASA crew. I was the one non-astronaut on the crew that conducted a 2-week-long mission at the Squyres laboratory in your home state of Florida, simulating the kinds of EVA, extravehicular activity, tools and equipment that one would use for exploration of an asteroid. And it got me very excited about what a human crew, a crew of human scientists, explorers could do at an asteroid on a mission that would be enabled by SLS. I think most importantly, a heavy lift capability is essential for someday sending humans to Mars. And you know, I'm a big fan of robotic exploration. I'm a member of the science team for the Curiosity mission. But what our magnificent state-of-the-art Curiosity rover can do in a day, you could do in about 45 seconds. And you know, what our magnificent Opportunity rover has done on Mars in 8.5 years, you could do in a good week and a half, something like that. So what humans can do in the way of science on the surface of Mars far surpasses what can ever be done, in my view, by these wonderful rovers that I've, and so many of us here, have devoted our careers to to building and operating. So I see SLS, heavy lift, and the ability to get humans beyond low Earth orbit as fundamental to some of the most important planetary science that we have ahead of us.
Senator Hutchison. And I might say that Senator Hutchison was key as we worked through the design of that NASA authorization bill to make the system evolvable so that it starts out what we have the funds and the capability for now, but it can grow to whatever the needs of the mission are.
Well, thank you. That was certainly a joint effort, and the purpose was to have the technology in the shuttle that's going to go to and from the space station that would be transferable to the heavy launch vehicle with Orion, so that we maximize efficiency with our taxpayer dollars. And that's what we have worked very hard to assure that NASA will do. When we talk about the importance of the robots and how exciting Curiosity is, nevertheless, Curiosity can't come back with the samples. Is that only going to be able to be done when we can put humans there that can return? Or are we looking at another technology feat that would be an interim of trying to get the robot down and bring samples back?
Sample return can be conducted robotically. And indeed, the mission that was recommended in the recent planetary decadal survey as the highest priority would have been the first step in a set of missions that would have robotically returned samples from Mars. Now, returning samples from Mars is in no way a substitute for the magnificent science that could be done by actually sending humans there. But what it does is it lays the scientific groundwork. It enables us to design a program of future human exploration of Mars that is driven, that is motivated, that is informed by the scientific results that come from those return samples, and gives the taxpayer the maximum return on the substantial investment that will be involved in sending humans to Mars. So we can bring samples back robotically. It's also possible to have humans play some role in that. You can envision many scenarios. You can envision scenarios in which samples are launched into orbit around Mars and then are retrieved by a human mission that goes into Martian orbit and comes back to Earth. There are many, many, many ways to play this game. But it is quite possible to do a return sample from Mars completely robotically.
And is that a worthy goal that we should be looking at for one of the, I think all of you and we have talked about the stages. I think your message is a clear mission in stages so that you accomplish a mission and that leads to the next mission and we know what that is. So would we be looking at something that would go to Mars while maybe the Curiosity might still be working, but yet another one that might have the return capability that would be a next goal to achieve, again, looking toward the human going to Mars as a goal down the road?
The Mars sample return campaign that was recommended in the planetary decadal survey would have kicked off with a launch in 2018, and it's still possible to do that. Different opportunities to launch a spacecraft to Mars are different from one another. Some are energetically more favorable than others. Turns out that 2018 is one of the best opportunities in the next few decades to actually land a substantial payload on the surface of Mars. And so it would be possible, given adequate funding, to do a mission in 2018 when Curiosity, we hope, will still be going, to put a rover on the surface that would select a carefully chosen cache, a suite of scientifically chosen samples, which would then be brought back to Earth by subsequent robotic missions further downstream. And that indeed was the primary recommendation of the most recent NRC decadal survey.
Looking at it from the congressional standpoint, where we also have to look at our financial situation and put money that is available toward the best priority, is that the best priority use of our exploration funds to do that? Or would it be better to not put the money on that returnable vehicle, but keep going toward the human vehicle as the next goal?
I would sincerely hope that it's not an either-or proposition. Certainly, as you compare Mars sample return to other missions that could be conducted in the field of planetary science by NASA's Space Science Mission Directorate, the single highest priority, as I said, that was identified via a broad 2-year consensus-building effort in the planetary science community was to begin this campaign of returning samples from Mars. Now, that was not an attempt to compare the value of Mars sample return to the value of future human exploration, SLS, Orion, or anything else. That was not the study that was conducted. My sincere hope is that, as has been the case over so much of NASA's history, robotic space exploration and human exploration can go forward in tandem, with one informing the other, motivating the other, providing a basis that drives us to send humans to these places. So I sincerely hope that we can go forward with this sample return mission without it adversely affecting what I think is the critical development of SLS, Orion, and the other vehicles that we need to move humans out in deep space, including Mars.
Do we know from what we have up there, whether it's something orbiting Mars or the rover, that the atmosphere will not be dangerous for a human in obviously a spacesuit, but do we know for sure from what we have evidence of that it will be safe for a person to actually land there and stay for a while?
We're in the process of obtaining that information right now. Curiosity has a number of instruments that will bear directly on that question. There is an instrument that is a radiation detector that is specifically there to characterize the radiation environment at the Martian surface as it would affect future human explorers. There's a capability to measure the composition of the Martian atmosphere to exquisite precision. We have an instrument that will tell us what minerals are present in the Martian soil, and you can infer from that what would be the effect of breathing that stuff in, that kind of thing. So we are right now, this is a great example of how these robotic missions inform the process of sending humans. Just as back in the early days prior to Apollo, there were missions that were sent to orbit the moon, to land on the moon, the surveyor missions to characterize the compaction state of the soil, what happens when footpads touch down on it, was the lunar module going to sink out of sight? We answered those questions with robotic precursors. We're doing the exact same thing at Mars right now.
Okay, I want to ask you, you said that we should prioritize the dollars that we have toward the best achievable goals in space exploration. And I believe all of you have stated that you're for robotics and you're for human, and you don't think they're mutually exclusive. Here's my question. Is NASA's mission too broad to be able to fully fund the priorities, and should we, in the next NASA authorization, look at splitting NASA so that we're now National Aeronautics and Space Administration? Should we, as an example, look at space exploration and put aeronautics somewhere else? That's just one example. Or are there other examples? So that's a twofer. Should we look at splitting NASA, or is the aeronautics and space function so closely intertwined that they're stronger and more appropriate together, even though we're spreading dollars now pretty thinly along with the science mission that is so important, like the Webb and the Hubble? So your suggestions as scientists on that issue.
Yeah. With regard to, there are other ways to slice up the pie, but with regard to aeronautics, it's performing several functions for the government and the FAA in particular that nobody else is. And actually, the amount of money that you would get for it, that you could devote to exploration, would be so small that I don't think it's worth the turmoil and disruption that would occur in a program that's already pretty small. As far as the rest of NASA is concerned, I believe that the way the science program is funded at about the $5 billion level gives us a shot at leadership in each of the fields that we are pursuing. And I think that is the criterion, and we have several that are, well, it gives us a shot at leadership in each one that we're pursuing. There's one area, I think, that is underfunded, which would be the utilization of the space station. And that actually is going to be critical in two ways. First of all, it'll prove to people that we're still doing things in space. And secondly, there are a number of critical basic science things that need to be learned to do the space technology of exploration. And just simply learning how fluids and pumps and various other things like that behave in space where there's no gravity will inform the design of systems that will go beyond low Earth orbit. That's just one example. So I think that the science program would suffer tremendously if it were cut off from the human and made separate from the human spaceflight enterprise.
Any differing views, or is everyone?
These are my views based on my experience here.
And is there are you basically saying, and I'd like any other view, that we are better off with NASA as a unit as it is, and there's not any part of NASA that you would jettison in order to get more of the money for the focus issues that we all agree are so very important?
I think you could look at each of the programs and ask, what should we not do in order to do something new in the future? But at this level of just, the basic elements of NASA, I don't see any value in separating them at the present time.
Yeah, that was going to be my comment is, as Dr. Squyres said, with the limited budget we have, we're asking NASA to be all things to all people. And so the first step in my mind would be, what are our true priorities? And at some point, I mean, in business, we do this all the time. I get requests for my research and development effort. Generally, every year the requests come in at twice my budget. And so we go through and decide, these are the priorities for us. And these, we call it the water line. Anything below that doesn't get funded. If something above it goes away or doesn't work out, then it can buy its way back in. But we make those hard choices. So the first step would be is, have we really made those hard choices and set a water line, and what then falls below it from a priority standpoint? But then the question comes, your question was, should we split it off somewhere else and have them not do it? If we still think it's important and someone else is doing it, we're still not saving any money. So if the objective is to work with a limited budget, I'm not sure just splitting it off and asking someone else to do it will save that. And so, Dr. Squyres, you suggested that we have some choices, and I agree. One of them is, I think maybe we have to pick some priorities. One of the other choices was maybe some of this effort could be shared with international collaboration, and so it reduces the total burden on one agency and one nation to fund it themselves, and we'd have to decide which areas are relevant for that. And then the third, you gave 4 choices, but those are the 2 that jumped out at me. But a third one we haven't talked much about, but we in industry have worked hard on is giving more results for less dollars. And so we have focused as an organization on how do we become as efficient as possible, and for every taxpayer dollar we spend through our customers, and not just NASA, we work for the Air Force also, how can we provide more for that limited number of dollars? Are we organized properly? Do we have the right footprint or square footage for what we need and who we need to be in the future going forward? And I think that's a legitimate question to ask.
Well, before we go to Dr. Squyres, the reason I opened the question of should we take some part of NASA that is considered maybe not synergistic with the purposes that we believe, science, aeronautics, and space, could it go to another place where it could be done more efficiently because it matches better? So the Department of Energy, maybe for some of the energy science that we're using the space station for, or something that in the Department of Defense for aeronautics. I don't know, but that's one way of at least looking at it. But if you're getting down to the priorities, then make suggestions on what you would put in the lower category from the scientific standpoint without the political overview. Are there programs within NASA that would get enough money over to space exploration or science to make it worth looking at lowering the priority? I know you, Dr. Squyres, mentioned that you have to prioritize, and you have, so is there a scientific view of what should be lower priority where you could add to the space exploration side?
Sure. I'd like to actually make two remarks in response to your question. First of all, let me just say a quick word about aeronautics. In my time as chairman of the NASA Advisory Council, I've personally come to the opinion that the aeronautics program is really one of NASA's shining jewels. It's a small part of the agency. It's the first A in NASA. It's a small part of the agency financially. But if you look at NASA's budget and you ask yourself, what are the things that the agency does that most directly benefit the taxpayers in their daily lives? It's hard to find anything better at NASA than their aeronautics program. And I fear that disrupting that program, trying to rip it out of the place where it's found such a good home and place it somewhere else could be detrimental to what I think is one of the best things that NASA does. With respect to science prioritization, the decadal surveys that are run by the National Research Council are pure exercises in scientific prioritization. And when we conducted the decadal survey, we look at dozens of mission concepts, and we winnow them, and we winnow them, and we prioritize, and we draw on inputs from the scientific community that go on literally for a couple of years. And then what we bring forward are the few highest priority missions that have survived that really pretty brutal down select process. So the missions that you see in the decadals are the highest priority. They're the ones that result from a very, very intensive and very rigorous prioritization process.
Yes, Dr. Kennel?
Yes, if I can add to that, one of the new things that we did in this round of decadal surveys was to try to impart some budget and engineering realism to our recommendations. And so in addition to scientists, we included engineers, and we got independent cost estimates so that we looked at the practical realities as well as the ideal scientific goals. And our recommendations were a result of those two types of considerations. And in the event, what happened was we recommended many fewer missions than we had in the past. And in fact, in our astrophysics survey for the entire decade, there were a number of smaller missions in an Explorer program, but only one lead candidate. And so there was winnowing that took place that we thought was fairly rigorous. The budget is going to winnow us even further. But when you look at those leadership recommendations and look through them, then it is still important, I believe, to try to stick to the goals that they laid forth, because those were analyzed for both scientific leadership purposes and realism.
Let me ask you this. You mentioned better utilizing the space station as one of the things that we ought to do, because there is a term limit on that of 2020. And one of the things that we put in our authorization bill was to make the U.S. part of the space station a national laboratory so that outside interests, other agencies, corporations, universities could actually buy experiments there and use it. My question is, what other ways would you have to further utilize and better utilize the space station that we certainly invested heavily in producing, and it has now been extended, which is great, but it's extended even though we can't get to it on our own with our own juice yet, but we will in the next few years. And what would you suggest is that we ought to be doing to better utilize it?
Well, first of all, let me just state that when the Augustine Commission basically recommended that we extend the lifetime of the station to 2020, we also suggested an indefinite extension in the sense that if people are finding it useful in 2018, they'll decide to continue. And it's that indefinite time horizon that is the important one that would enable people from the non-NASA community and from the outside world to have enough sense and knowledge that the resource will be there, that they can then begin to plan long-term utilization programs. And so I think being open about the date that we close the station is terribly important. Secondly, if you really look at it, the Europeans are doing a much better job of utilizing the station that we built than we are at the scientific level. And the reason is they weren't burdened with the financial difficulties of building it, and so they planned for the long term, and they've developed stable scientific communities that look at the issue, that all of the things that you can do in low gravity that you cannot do on the Earth, whether it's fluid behavior, biological behavior in particular, and they have basic science research as well as engineering going forward. Financial exigencies and program changes eviscerated our community in that field. And that happened about 2005 or 6. And our report recommends that we rebuild that community. And we're very pleased that NASA has made a good faith effort to do so. They've created an office, and with their limited resources, they are trying to rebuild a community that has lost faith, to be quite frank, that the station will be there for them. That's why the NGO is needed, to make it easy for them to participate. The long horizon is important for them so they can be secure that they can commit their reputations on station. And quite frankly, the funding that that office has is far less than the funding we used to have. And so I think a requirement for the U.S. is for U.S. scientists to begin to use it. And I think by 2020, if you begin to see U.S. scientific results coming out at the same international level that we're used to in all of the other fields of science, then I think people will no longer say that the space program is dead because we don't have the shuttle. They will say, oh, America's doing lots on its space station. But right now, the Europeans are getting more science out of the space station that we built than they did, than we are.
I have a specific suggestion regarding space station utilization. If you're, say, a university researcher who is interested in doing research in a microgravity environment, there are substantial barriers to trying to get an experiment on board the space station. There is a level of review and oversight, what some researchers might view as excessive attention to minute details of experiments that are daunting to many university investigators. It's just too hard to get through that process and get your hardware on board the space station. So anecdotally, there are researchers who just choose not to try it because they don't want to jump over those hurdles. Now, the reasons for the existence of those hurdles are absolutely sound, and they're crew safety. And crew safety can and must never, ever be compromised. But now that we have years of experience in operating the space station, I think it might make some sense to look carefully at whether or not there's a gap that could be widened between what's really necessary to safely fly something on the station and what the current set of rules, requirements, reviews, and oversight demand. And if that gap could be widened a little bit, reducing the barrier to getting universities, getting other organizations to fly experiments on the space station, just making it easier to do business in that precious national laboratory, I think there could be some benefits to the nation.
Thank you. That's very helpful.
And if I could add, this barrier that he so cogently described is the one that we thought the independent NGO organization could overcome, that there's a culture, that what you really need is a professional organization who can take the requirements and hopes of a space-naive community and translate them into terms that the operational community can tolerate and work through all of the issues and not make the poor scientist out there who's never before worked in space try to deal with it. So you need a professional professional opportunity translation organization. And that is why we thought, and there's an example in the Space Telescope Science Institute that has guided my thinking, but something like that is needed to actually translate opportunity into reality on station operations. But at the end of the day, the provision of access to the zero low gravity will be an attraction to many scientists if they can actually get at it.
Okay, let me ask you, I have a couple of other questions. One is on you said we should have more, not just participation, but real use with our international partners in both, obviously, the space station, but in space exploration. Do you have any specifics on what more we should be asking and realistically expect from our international partners?
Sure. Let me give you 2 examples. In the area of robotic space exploration and particularly sample return from Mars, there are several necessary elements to a sample return campaign. One is a rover that can land on the surface and collect and cache a suite of samples. Well, that's something we know how to do pretty well at NASA, so maybe we don't need any help with that one. But you also need a vehicle that can get those samples off the surface and into orbit around Mars. And then you need a vehicle that can find that little spacecraft that you've launched off the surface. It can rendezvous with it and bring the samples back to Earth. On-orbit rendezvous, planetary orbiters, these are things that many potential international partners know how to do and know how to do well. And so I think there is significant potential, and indeed that was the intention of the Planetary Decadal Survey recommended sample return campaign, was that it would be conducted in partnership with other agencies, particularly the European Space Agency.
Why aren't we doing that?
The reason that we're not doing that at the present time is the cuts that were projected to the FY13 planetary budget made it impossible, projecting the budget forward, to carry out that HOPE-4 mission in partnership with ESA, and so NASA walked away from the partnership, at least temporarily. My hope is that that can be corrected in the future. With respect to human exploration, I made the point in my opening remarks that we have 2 magnificent pieces of what you need for truly enabling deep space exploration, the Orion and SLS. But Orion and SLS alone will not get you to the surface of the moon. They will not get you to an asteroid. There are other vehicles, a lunar lander, a deep space habitation module that can support a crew for the time that it takes to actually get to an asteroid, propulsion capabilities, in-space propulsion capabilities, that sort of thing. I think those are all potentially components of a true deep space exploration system to which international partners could potentially be invited to contribute. And so, you know, I in my opening remarks, I stressed that there's a big piece of the puzzle missing. We say we want to go to an asteroid. We'd say we'd like to maybe go back to the moon. We certainly want to go to Mars. But right now, we've got the ability to launch a lot of mass off the surface of the Earth in work with SLS, and we've got the abilities to support a crew of 4 for 21 days with Orion. And those are magnificent and necessary capabilities. They are necessary, but they are not sufficient. And so I think looking to capable, committed international partners, as we've done so spectacularly well with the International Space Station. I mean, what a triumph that has been, is something we should be looking at.
Mm-hmm.
Yes, Dr.
So I would just like to add to that. The International Space Station partnership is a miracle of international relationships. It has survived budget ups and downs, our accidents, various defaults on the part of other partners, and yet it continues to this day. It's 14 nations working together on the station. And if you think, for example, that someday that the world will go to Mars led by the United States, then you're going to need something like the space station partnership and the confidence building that has already taken place to also participate in that mission. And so there is a policy issue that you may wish to consider, and that is that as people renegotiate the International Space Station partnership, you could add to it some goals that are related to the development of the technology for beyond LEO exploration to the space station partnership, so that they begin to develop an awareness of the really great challenges and technical challenges that will face all of us as we try to get to Mars, and we begin to enlist them in the effort. And that could, I don't know whether that would serve as a precursor for the partnership that we would build, but it certainly would be a confidence builder, and I think it would help start the process off in a way that is useful to the United States.
One other comment I would add to that is we're all aware that the space station was nearly canceled, right, within one vote. And a lot of people have said one of the main reasons it went through is because of our international commitments. And I would argue, you know, a big part of my argument has been about an enduring, stable vision of incrementally increasing challenges. And if we committed to that and committed to a collaboration internationally for that over the long run, perhaps that's a model in which national commitments to each other create some stability and can get us out of this cycle of starting and canceling things, because it goes beyond any one administration or any one congressional period, because the commitments are multi-decade.
I think what you all are doing is actually putting forth the long-term clear goal that you discussed as the first policy directive, because it would take certainly to get our international partners to re-up into this bigger coordination effort, the assurance that we wouldn't have fits and starts. And one of the things in my time here that I have worked with administrations that are Democrat and administrations that are Republican, and have tried to say you can't just say we're going to stop doing something that we have international partners already investing in to a great degree from their own budgets. Their percentage of the budget they're putting in is as big as the percentage of our budget. And we've got to be a reliable partner in order to keep an alliance like that going. And if we're talking about the kind of commitment that you suggest, which is putting different vehicles, capabilities together so that it doesn't all fall on us, nevertheless, we are going to have to be reliable and show that we're not going to get cold feet midway through this and all of a sudden stop our part. And I think that's a worthy goal for the clear, stated, visionary goal for the future. And I think you've sort of put together a nugget that really could be the basis for the next authorization bill. Last question, and then I will turn it back over to the chairman. And that is, we've seen really an emergence of commercial capabilities A lot of our U.S. tax dollars have gone into helping the commercial operators begin to get the capabilities to at first do this taxi to and from the space station. Are you at all concerned about the money that goes into the commercial operation taking from the future heavy launch with the discussion that we've just had? Or do you think that we can do both efficiently, having the taxi to the space station and perhaps allowing it to be extended, as Dr. Kennel suggested, because you have the taxi capabilities going forward beyond 2020, and maybe it could maybe not pay for itself exactly, but certainly offset much of the expense of holding on to the space station, while we at the same time focus our efforts at NASA on the next generation, the beyond low Earth orbit exploration.
I think if we're smart about it, we can do both. And let me give an example. We were just talking about the importance, potentially, of international partners bringing pieces to the puzzle to create a more robust deep space capability. But the resources to do that within ESA or wherever, they have to come from somewhere. If you look at ESA's, for example, if you look at some of our international partners' commitments to future space station activities, some of them have to do with resupply. Some of them have to do with providing upmass, getting stuff up to the space station. If, as a result of investment in commercial capabilities, the recent Dragon mission to station being an example, and more to come, I hope. If we develop a robust capability here in this country to do that resupply, to get that upmass to the space station, it could offload some of these foreign partners from some of the resupply that they're currently committed to providing, and they could take those resources and they could put it into something else that would take us deeper out into space. So I think if we're smart about how we play this game, there are efficiencies that could come from commercial taxis, if you will, to the International Space Station that could provide benefits that could then be felt in the deep space part of what NASA does.
Thank you. Dr. Kennel.
Thank you. There's no long-term future unless you provide value in the short term. And so the trips to the station are providing value in the short term. And the commercial enterprise, if it proves to be successful, I think is going to broaden the social base and technology base for the larger enterprise to come. So I think that's a useful thing. There's another dimension of this problem that you may not become aware of, but recently, with the cancellation of the Delta rocket system, the space science community has become concerned about the lack of availability of mid-scale rocket systems for scientific spacecraft. So there's a kind of unfocused hope that if the commercials are successful, then we will also be able to tailor some of our experiments to those capabilities. I haven't quite seen the study yet, and I think it's delicate at the commercial level to do it. But I do believe that there is a possibility that the successful commercial industry will also help space science.
I guess my comment is, first and foremost, I think we all agree we need access to station from the United States. And so given that, both cargo and crew, and given that, we want to do it as affordably as possible. And Neil deGrasse Tyson said low Earth orbit is where hundreds have gone before. And I think the point behind that is we've been doing that long enough. We should be able to do it very cost effectively and potentially buy those services in a different manner than we've traditionally procured them as a NASA-owned and operated vehicle. So I'm on board with that completely. And certainly cargo, as a separate launch vehicle and a separate system, we can take more risk. We can afford a little bit of failure in there, and I think that's good. The real question in my mind is, as you shift to commercial, we're not going to be as risk tolerant. You have the lives of people on board, and you have the space station that you absolutely have to be careful with from that standpoint also. And so when I stand back and look at it, my question and comment would be, are we absolutely certain that the approach we're taking is the quickest, most cost-effective, and safest way to take things to station, especially people? And how many systems do we really need under that context with the amount of market there is out there? Because when I look at particularly commercial crew, when I stand back and look at it, if station were to end in 2020, the commercial crew people would end up, if there's 2 providers, would end up launching each once a year for maybe 3 years or 4 years or something. So maybe station will be extended, but the real question is, for the most effective use of dollars, how many commercial crew providers do we need in the long run? That's my question.
We've certainly tried to lower the number of commercial operators that are going to get the federal seed money, right, just because I think we agreed that that was just more than we could take away from SLS and Orion, but now they're at 2.5. And so
that was positive movement. I think that's good to get to the next point. And I think as it evolves to the next decision point, I think clearly we need to look at how many real missions are there out there and how many suppliers are appropriate.
Well, the goal is to have 1. So that's the goal, and that would, we're looking at the efficiency and making sure we're not paying just as much as we would had we kept it all in NASA. And I think the down select, which we pretty much forced, is a step in the right direction, but hopefully there's 1 more down select, and based on the merit, whoever wins will be the one, hopefully. Well, thank you very much. This has been very, very helpful, and I think that it really will inform us as we go forward into the next authorization period. And fortunately, even though I'm leaving, there will be others who will be staying, and the staff will hopefully stay, and we will use this very helpful information to look at the importance of a goal that can be achieved with international cooperation. I like what you've said. Thank you very much.
Thank you.
Thank you, Senator Hutchison, and thank you again for your leadership over the years on this topic that you are very, very passionate about. I just want to say, Mr. Mazur, that the value of competition is that instead of your rocket company being the only one in town, you get sharper, your prices get sharper if there is a competitor there, and that's the whole idea of this competition for the way to get to and from the International Space Station. So over time, that the bringing of the cost per pound to get to orbit comes dramatically down. I want to ask you all on our topic of exploration beyond Earth orbit. Doesn't it appear right now that with conventional technology that we couldn't do, assuming that we can build a lander and all of that, and that we know what we're landing on and we've returned a sample so we can know what to expect. But right now, it's going to take us 8 to 10 months to get there. Once you're there, then the planets are out of alignment that you've got to wait a long, long time before you can bring the crew back to get the planets closer in alignment. So aren't we really talking about going to Mars in the 2030s for the first crewed mission, that we've got to develop a whole new propulsion system that's going to get us there a lot quicker? What do you think about that?
Personally, I think that it's possible to do a human mission to Mars using advanced but chemical propulsion systems. I don't think we need a dramatically new technology. There are technologies that will be beneficial. One can imagine some aero capture sorts of deceleration technologies that could be used at Mars. certainly for some of the transfer stages that we might want to use to get crews to Mars, having the ability to do in-space storage of cryogenic propellants would be a good thing. But I think if you were to conduct a poll in the astronaut office right now, who would be willing to sign up for a mission of that duration to Mars, you'd get a lot of takers. So I personally believe that the biomedical issues that are associated with long-term exposure to microgravity and the effects on a crew on the way to Mars and back are being addressed now pretty impressively on the International Space Station. I think that's one way in which ISS is really contributing to future human exploration. So I don't think you need a totally different approach to in-space propulsion in order to safely get humans onto the surface of Mars, have them be effective while they're there, and get them back. But there are technological developments, and I think in-space storage of cryogenic propellants is very high on that list that will be enabling in that regard.
Dr. Kennel?
I'm not going to challenge Steve's judgment because I actually agree with it as things look at the present. However, what I'd like to say is that the commitment to the goal probably is going to stimulate all sorts of technological innovations. People are going to try things to try to shorten the flight time. They're going to try various biomedical remedies and so forth because they know the goal will still be there. And as soon as you make it clear that we're going to eventually go beyond low Earth orbit, I think you will find people willing, just like the entrepreneurial space launch industry, you will probably find people willing to take a risk on new technologies, and experience tells us that every now and then there's a breakthrough. And that may accelerate. The goal will be for those technologies to accelerate the time that we shove off from low Earth orbit and actually make the first mission. And so I think setting the goal is terribly important for eliciting potential innovations.
I want to wrap up the hearing with just a couple of questions about the funding and the certainty of the funding. Now, we're living in uncertain times with the budgetary situation as it is. If you look at NASA as a federal agency compared to other federal agencies, it has fared quite well. And yet, what is the future? Sequestration, this meat cleaver that's hanging over the federal budget at the end of the year was never intended to take effect because it was the meat cleaver to force the House and Senate Joint Supercommittee to come to agreement, and we know what happened a year ago. That didn't happen, and so we are facing those consequences. But I think we'll work ourselves through that and avoid the sequestration. But still, the uncertainty of the funding of the future, and Mr. Mazur, we're getting ready probably tomorrow to enact another appropriations bill called a continuing resolution, taking the existing funding from this past fiscal year and applying it probably for the next 6 months. That creates uncertainty for NASA programs and contractors. How in the past have the continuing resolutions affected NASA programs and contractors?
Well, this year might be a good thing. I don't know, relative to what we've been looking at potentially. But generally, what we look for is a view to what funding's going in out years, and we size and organize around those. And then as a budget isn't approved, and you go into a continuing resolution, activities and scope and funding for things you had planned on, staffed for, and organized for don't materialize, and you're forced to move people around and shift priorities, and in some cases you can't adjust your costs fast enough that you just have to pass on the cost increase to the customer in the short run. In the past few years, there's been probably I think it's even been more discontinuous than the transition from the end of the Apollo program to the shuttle program, because there's actually quite a few years of overlap in development activity. So even though Apollo was ending, shuttle had started years before its first launch, and it continued to keep going. And so that actually provided, even though it was much reduced in terms of what it was during the Apollo era, you pretty much knew where it was, and it wasn't discontinuous. In the past 3 or 4 years here, we've seen the end of the shuttle, cancellation of Constellation, no decision at all about what we were going to do next. Finally, a year ago, a decision was made. But every year...
2 years ago.
It was 2 years ago? I thought.
Not,
well, the authorization was 2 years ago, but the SLS was a year ago. The actual decision on the SLS, I believe.
No, sir. The authorization in 2010 set the course, the blueprint for the SLS, and said the parameters. Now, you're talking about the funding of it. Well, the funding, and there again, I thank Senator Hutchison, because she's on the Appropriations Committee as well. The funding started to implement the authorization bill for the development of the SLS and Orion. And, of course, in appropriations process, you always have these pulls and tugs, and then with the overall attempts at slashing federal spending on everything, that has complicated. Go ahead and make your point.
That's true.
I just wanted to correct that.
Thank you. So the ultimate comment I would make is every year in 2010, 2011, and 2012, we have made reductions down to the size we felt would be appropriate for our business going forward, starting in 2010. As we get towards the end of the year and we look towards what's going forward in the future in terms of budgets, how money's being allocated, funding, et cetera, we had to make additional reductions, and this is my third year of reductions. And every year I say, once I get down to that level, I'll have a stable employment level about which I can manage fluctuations with overtime and basically temporary workers. And so that's the intent we're doing this year. We're continuing to reduce staff. We're down about 30% in staff over the past 3 years. And the continuing resolution, sequestration, and the lack of stability creates a tremendous amount of nervousness within the organization, within our people, about what the future holds for them. And it creates a big challenge for attraction, retention, and motivation going forward. So we can organize and size for any future, but we would like to see a view as to what that future looks like and some stability for the long run. Competition's fine. We're happy to compete, and if we lose, we'll make adjustments. We'd love to go compete for those items that we put out there in the future, but to have them not funded and never even be able to compete for them, or to compete and win and then have them canceled, is a real challenge for our organizations.
Dr. Kimmel, I would suggest that in your position with the NRC's Space Studies Board, you might want to have them look at this topic, the impacts to the space program of the different funding scenarios, including sequestration, even though this senator doesn't think sequestration will go into effect, or if it did go into effect because of lack of agreement by December 31st, it will quickly be overturned in the new Congress. So I would suggest that you all take up that topic fairly soon.
And we have given this some thought, and it's quite clear that giving the decision makers a sense of what is at risk at different levels of reduction will, I think, be very useful. It will be difficult, I think, for us to do it over the next 3 months, but I think over the longer term we can look at levels of cuts or changes in budget and how we might respond, and we would do so with reference to the goals thus far that we have set forth in our decadal surveys, unless we're directed to look at it differently. But I think we could, knowing our goals, we could say what we would do under different scenarios.
Dr. Kimmel, it would also be helpful if you could report from the NRC to us on the committee on an evaluation of the administration's plan under the NASA authorization bill for the exploration program with regard to Mars. That would be very helpful.
Yes, I would be delighted to consider that. We'd have to work it out very carefully, of course, but we very much want to see what the new NASA committee is saying. We very much want to evaluate it.
Good. Senator Hutchison, any further? Well, this has been most illuminating. Thank you all. The meeting is adjourned.